Hello my dear children, this is class 11th. We have already completed chapter structure of atom. In part wise I have completed the chapter structure of atom. Now today I am going to start the MCQ of structure of atom. I am going to give some tips of this chapter. First of all, write down Bohr's atomic model. I am going to give the tips of Bohr's atomic model and few MCQ questions regarding that. After that, I will give you one link where you can attempt MCQ type questions. Write down the few tips regarding Bohr's atomic model. First of all, first point, write down this model is based on single electron species. Those atom or ions have single electron. This model is based on that. That is hydrogen with a single electron, helium plus again with one electron, lithium 2 plus with one electron, beryllium 3 plus with one electron. So first point is this model is based on single electronic concept. Those atom or ions have single electron. We can calculate their energy, their radius of the orbit, velocity of the electron by applying some formulas of Bohr's atomic model. Second point is, according to Bohr's atomic model, energy of the electron and the angular momentum of the electron is quantized. Energy as well as angular momentum. Momentum of electron present in the orbit or shell is quantized. Quantized, you know what is quantized? I told you in my descriptive lectures, quantized means a quantity of energy which vary discontinuously but not continuously. So second is energy and the angular momentum. Today I will tell you how to find the energy, how to find the angular momentum. After that, write on the third point is, in Bohr's atomic model, you know all, in the center there is a nucleus. You know all about this Bohr's atomic model. In the center there is a nucleus where proton and electron lies, that is nucleons lie, and electron revolve in the fixed orbit, that is K shell, L shell, M shell, N shell. According to Bohr's model, ground state of single electron is N is equal to 1. That is a K shell. K shell is the ground state of electron. It is a ground state of electron. And in all these cases, they have single electron, and single electron first lies in N is equal to 1. After giving them energy from outside, they get excited to various levels depending upon how many photons they are absorbing. The third is Bohr's atomic, next point is Bohr's atomic model based on the particle nature of electron. You know, light has a wave character as well as particle character. In the same way, electron is a particle as well as wave. So this model is based on the particle nature of electron. Now I'm going to start mathematical work of this model. Write down, first point is how to find the angular momentum. To find the angular momentum of electron in any orbit, in any shell, it is equal to NH by 2 pi. Angular momentum is mvr, but to find the angular momentum of electron in any of the shell, you apply N is the 1 when there is a K shell, you know all, N is 2 when the L shell, N is 3 in the M shell, N is 4 in the N shell, and so on. So when you find the angular momentum of electron in a subshell, that is the first A part, angular momentum of electron in subshell. subshell and shell. It is under root L into L plus 1 into H by 2 pi, or you call it H bar. If you want to find the angular momentum of electron in a shell, apply NH by 2 pi, and other is you apply under root, in a subshell you apply under root L into L plus 1 into H by 2 pi, that is H bar. Now after that you write the radius. Third point, this is your angular momentum calculations. Okay, now you write the second is to find the radius of, to apply radius of any shell, it is equal to 0.529, you may take 529 into n square by z. So you take this formula, radius is in meters, 0.53 into n square by z. What is it, z? It is atomic number of atom or the ions which has a single electron. Next is, this radius is in angstrom. Radius. To find the radius, the formula is this. Now I am taking few questions regarding radius. Write the first question. Calculate the MCQ type question I am taking. Calculate the radius of third and the fifth orbit of helium plus, and also find the ratio. Calculate the radius of the third and the fifth orbit of helium plus, and then find the ratio. Question number 1. Find the radius. You know what is the radius? Radius is equal to 0.529 or n square by z. Z is atomic number, it is 2 for helium. So if the radius of the third orbit you want to find, you write radius of the third orbit 0.53 into 3 square divided by 2. Radius of the fourth orbit is divided by, it is again 0.53 multiplied by 4 square divided by 2. So this is the answer. So what is the ratio? Ratio will come radius of the third and the fourth orbit. Radius of the third orbit by radius of the fourth orbit. 0.53 and divided by 2 cancel. You left with 9 and 16. So this is the ratio 9:16. Now I am taking next question. Calculate the second question regarding radius. So radius is angstrom, it is 0.53 into n square by z angstrom. Second question, calculate the radius ratio of the second orbit. Calculate the radius ratio of the second orbit of hydrogen. Second orbit of hydrogen and third orbit of lithium 2 plus. Very simple again. So it is, radius of the second orbit of hydrogen, it is 0.53 into n square. N square is 2 square by z is 1. Atomic number of hydrogen is 1 divided by radius of the third orbit. It is again 0.53 multiplied by, now it is n square is 3 square and the z is the atomic number. Z, the atomic number of lithium is 3. It's not helium, it's 3. So divide these two, what the answer comes? Radius of the second by radius of the third, your 0.53 cancel, your answer will come 4 divided by 9, and it's 9 by 3, so 3 will come here. So it is 12 by 9. So it is you can cancel, it is 4:3. Now your answer is 4:3. Second question we have covered regarding radius. Now I am taking next question, third question regarding radius of any of the orbit but of single electronic species. The ratio of the Write down third question. The ratio of the radii of the two Bohr's orbit. Ratio is given now. The ratio of the radius of the two Bohr's orbit is, in case of lithium 2 plus it is mentioned. The radius ratio is given, it is 1:9. Radius ratio is given. The question is, what is the nomenclature? So you know what is answer. Radius of N1, radius of N2. It is equal to 0.53 into N1 square by Z divided by 0.53 into N2 square by Z. And this ratio is given. It is 1:9. This ratio is given. Now this ratio is given, but the Z is lithium 2 plus. That is lithium 2 plus Z is hydrogen, helium, lithium. It is 3 mentioned. This ratio, total ratio is given. So what you will do, after that, this radius ratio is given. Then you will take 1/9. Radius ratio is given. It is equal to N1 square by N2 square. What would cancel? 0.53 cancel. Atomic number is same, cancel. So this comes, radius ratio is 1/9. So you're taking square root on both sides. Your answer will come 1/3 is equal to N1/N2. So what is the nomenclature? One shell is first shell, other shell is third shell. It's K shell and M shell. The nomenclature is. So sometime radius ratio you have to calculate, and vice versa. Sometime radius ratio is given and you will find the nomenclature. Nomenclature means the orbit names. So this is about the radius ratio. Now I'm giving you 1 or 2 questions. You can attempt yourself. Alright, the next question is, calculate the radius of the second excited state of lithium plus. Second excited state of lithium 2 plus. Calculate the, I'm giving you hint, calculate the radius of second excited state. You know, I told you very first second that the N is equal to 1 is the ground state. The first excited state, when the electron moves from N is equal to 1 to N is equal to 2. It is the first excited state. The second excited state, when electron moves from N is equal to 1 to N is equal to 3. That means you have to find the radius of the third shell. Again listen, the question was, calculate the radius of the second excited state of lithium 2 plus. Formula you well know, the radius of the third orbit. It is 0.53 into 3 square, and atomic number of lithium is 3. Z is 3. After that I am taking your question. Calculate the radius of the second excited state of hydrogen and first excited state of lithium 2 plus. Write down. Calculate the radius of the second excited state of hydrogen and first excited state of lithium 2 plus. Right, and the answer is 27/4. 27/4. Again listen. It is 27/4. So what topic we have covered? I will complete Bohr's atomic model today. We have completed 3-4 points. That is the theoretical portion is according to Bohr's model, energy and the angular momentum of the electron is quantized. If you want to calculate the angular momentum, you apply the formula nh/2 in an orbit, and in a subshell it is under root L into L plus 1. And after that, Bohr's model is on single electron species, the hydrogen, helium plus, lithium 2 plus, and helium, that is your beryllium 3 plus. And after that, radius of any of the orbit, 3-4 questions I have taken. The one question I have given to you for practice. Right, and the next is, after calculating radius, write down the energy. Energy of electron in any orbit. In any orbit. Two formulas. The one is energy of electron in any orbit is equal to minus 2.18 into 10 to the power minus 18 into, that is by n square, it's n square into z square. But this is in joules per atom. You want to calculate the energy, it is this. After that, it is your energy, it is electron volt minus 13.6 into z square by n square, that is electron volt per atom. So you can calculate energy, you know, all in descriptive topics I have covered. Electron has not its own energy. Electron acquire the energy of any of the orbit where it goes. So energy of the electron in any of the orbit is quantized, means fixed. So energy, the first shell, you put here 1 square. Z is the atomic number and this is your electron volt per atom. And write down more formulas, sometime kinetic energy and the potential energy may also come. Write down potential energy is equal to minus 2 kinetic energy. More formulas, but this is the best formulas and very popular to calculate the energy of the electron. Sometime in some of the exam, potential energy, total energy, kinetic energy may also come. Kinetic energy is equal to minus total energy. It is, you know, E, capital E is a total energy, rest kinetic energy and potential energy. And that means potential energy is equal to minus 2 of that is total energy. Now I am taking some of the question regarding this. Write down first question of calculation of the energy of electron. The question is, first question is, calculate the energy of the lithium 2 plus. Lithium 2 plus in the second excited state. Second excited state. Second excited state, again n is equal to, first excited state is n is equal to 1 to n is equal to 2. Second excited state is n is equal to 1 to n is equal to 3. Second excited state. So calculate the energy of electron of lithium 2 plus. Formula is energy of the second excited state is third orbit. Third orbit is equal to minus 2.18 into 10 to the power minus 18 by n square. N square is 3 square into z square. So it's hydrogen, helium, lithium. Atomic number is 3. So it is into z square. So 3 square. So this is your answer. Your answer, either you can calculate the answer is electron volt per atom, but this answer is in joules per atom. So this is the first question that we have covered. Right, and the second question is, calculate the ratio of the energy of the first and the second excited state. Calculate the ratio of the energy of the first and the second excited state in case of helium plus. Helium plus. Now first excited state, when electron jump from n is equal to 1 to n is equal to 2, and second excited state, when electron jumps from n is equal to 1 to n is equal to 3. You have to find the ratio in case of helium plus. Let me calculate now. Now its energy of the second orbit, it is minus 13.6 you may take. Your answer will come in electron volt into z square. Z square is helium. Helium atomic number is 2. It's 2 square by n square. Next is your third shell. It is again minus 13.6 into 2 square. It is into z square by n square. So you divide these two. It's E second shell energy and the third shell energy. Minus 13.6, 2 square cancel. Your answer will come. It is 1 by 4 and it is 1 by 9. So it is come 9 by 4. So this is 9 ratio 4. Now I'm taking next question regarding potential energy and kinetic energy. So it's very easy to find the energy. It's very clear now. Now I'm taking question is if the potential energy of the electron is, now potential energy is given. Potential energy of the electron is minus 6.8 electron volt. Potential energy of the electron is given minus 6.8 electron volt in hydrogen atom, and calculate the kinetic energy. Very simple answer. You can apply this formula. Potential energy is equal to minus 2 kinetic energy. So divide it by 2. So this will come your kinetic energy. Now after that, they also wants to calculate total energy as well as the orbit where electron exists and the radius of the orbit. Right, thoroughly calculate the potential energy and also find out calculate the kinetic energy. Potential energy is given. Calculate the kinetic energy as well as the total energy and the orbit where electron exists. We have to find the orbit where electron exists and radius of the orbit. Now this is your potential energy is given. How will you calculate kinetic energy? You know potential energy is equal to minus 2 into kinetic energy. So your kinetic energy will come potential energy divided by minus 2. So your answer is minus 6.8 divided by, so this your answer is, it is your 3.4 electron volt. After that, calculate total energy. So potential energy is equal to minus 2 of total energy. So now you calculate total energy. So total energy is equal to potential energy divided by minus 2. So your answer will come that your answer after calculating your answer will come 3.4 electron volt. Now when the total energy is there, you can calculate now this energy is there, energy minus 13.6 into z square by n square. Now you calculate n square and your total energy is given now. Now you have calculated just now total energy. You put here total energy. Z is 1 for hydrogen and calculate n. After calculation of the n, the answer will come 2. So you calculate the radius. Radius of the second orbit is 0.53 into n square by z. Again, z is 1 for hydrogen, n is a 2 square. So very interesting question. Calculate potential energy is given. You have to calculate kinetic energy. Apply the formula kinetic energy is equal to potential energy by 2 minus, that is after that again potential energy is given. You have to calculate total energy. After calculating total energy, you apply the formula total energy is equal to minus 13.6 into z square by n square. Calculate n square, n will come 2. When the n will come 2, you calculate the radius of the orbit. So this is a way to calculate energy, radius, angular momentum. Now the last left, velocity. Now velocity of the electron in any of the orbit is a meter per second. Apply the formula 2.188 into z by n, meter per second. So this is the formula to calculate the velocity of electron in any of the orbit. Write on one of the question regarding velocity. Question: calculate the velocity of the electron present in the third orbit of hydrogen atom. So third orbit of hydrogen atom, 2.188 into hydrogen atom, z is 1 and third orbit is. This is the answer, very simple. Calculate the velocity of the electron in the third orbit. Also calculate the number of revolution or how many rotation it undergo in 1 second around the nucleus. So there is a formula. It is the velocity, number of revolution around the nucleus per second is, it's 2 pi velocity of that orbit divided by 2 pi r. So it is a number of the rotations of electron around the nucleus in 1 second. So you calculate velocity and put here, it's 2 into 3.14 and radius again by applying 0.53 into n square. N square is the second, I think it's the second orbit, yes, third orbit, into n square by z. Z is 1 for hydrogen. So this is the formulas related with the single electronic species about velocity, radius, energy, total energy, kinetic energy and potential energy. Few points you may write in theoretical portion. Write down: when radius increases, kinetic energy decreases. Write down the point: when radius increases, kinetic energy decreases. Second point: when radius increases, potential energy as well as total energy increases. Only kinetic energy decreases, radius increases, kinetic energy decreases, but potential energy increases as well as total energy increases. So this is all about. Now I am taking few questions from the spectral lines. Spectral lines: Lyman series, Balmer series, Paschen, Brackett, Puffin and Humphrey series. You will first of all write, there is a formula, N2 minus N1, N2 minus N1 plus 1 divided by 2. Write down, this is a formula to calculate the number of the spectral lines. There is one more formula, N into N minus 1 by 2. These are the two formulas to find the number of the spectral lines when electron fall from excited state to ground state. Now I am using this formula, very important formula. I am using this. Question number 1. If electron moves from 7th orbit to the 1st orbit, calculate the total number of lines in the spectrum. If electron moves from 7th to 1st orbit, how many total spectral lines obtained? 7 to 1st, when direct to 1st, you apply this formula always. So put here N is 7, so it is 7 into 7 minus 1 by 2, so it is 21 lines, that is 7 into 6 by 2, that is 21 spectral lines. Now second question, this formula you can use only then when your electron falls from excited state directly to n is equal to 1. Second formula. Now how will you use it? Write on a question related with this. Calculate the total number of spectral lines obtained when electron jumps from 6th to 2nd orbit. 6th to 2nd orbit. 6th and 2 to 2nd orbit. It is 6th to 2nd orbit and then plus 1. That is divided by 2. The answer is 6 minus 2, 4. It is 4. After that, it is again multiplied by, it's multiplied. It is 4 plus 1 divided by 2. The answer will come 4 into 5 by 2. It's 10 spectral lines. I'm taking next question, number 3, about the spectral lines. Now next question is, how many spectral lines obtained when electron jumps from 6th to 3rd orbit? You buy here 6th and your N1 is 3. That means you came to know how you can calculate the total number of spectral lines. Now after that, few calculations regarding spectral lines. There is a formula, wave number, Rydberg occasion. To calculate the wave number, energy, wavelength of any spectral line, it is R 1 upon N1 square minus 1 upon n2 square into z. Now write down the question number 1 is z square. Question number 1 is calculate the wave number of the third line of Balmer series. Calculate the wave number of the third line of the Balmer series. R is a Rydberg constant. Write down its value is 1.1 into 10 raised to power 10 per meter. So its value is 1.1 into 10 raised to power 7. Because so many constants, it's 10.78 into 10 to the power 6. So very simple, 1.1 into 10 raised to power 7 per meter. So I am taking, calculate the wave number of the third line of the Balmer series. If the question comes, calculate the wave number of the third line of Balmer series. What you will do, students? Lyman, Balmer. For Balmer, N1 is 2. Third line, you will add this. So you will add the number of the line in the ground state. So N2 is 5. You put here your Z is 1 for hydrogen, 2 for helium plus, 3 for lithium 2 plus, and 4 for beryllium 3 plus. So Z is 1, 2, 3, 4. 1 for hydrogen, 2 for helium plus, 3 for lithium 2 plus, and 4 for beryllium 3 plus. All these have single electron. R is Rydberg constant, 1.1 into 10 to the power 7. Third line of Balmer series means Lyman, n is equal to 1, Balmer, n is equal to 2. Line number third, it is 2 plus 3. Next question, calculate the wave number of the fifth line of bracket series. Fifth line of bracket series. So it's Lyman, Balmer, Bastian, bracket. N1 is 4 for bracket series. So N2 is 4 plus 5, that is 9. So you put N1 is 4, N2 is 9, Z, whatever the species or ion will come. Now I'm taking few questions from MCQ book. I'm taking first question is, calculate the frequency of the last line of the Lyman series. Last line, students write last line, limiting line, and marginal line. Last line, limiting line, and marginal line is infinity. Next, write initial line, starting line, fine line. Initial line, starting line, first line is it depends upon the name of the series. Lyman series, it's 1, Balmer series is 2. Now I'm taking your question, calculate the frequency of the last line of the Lyman series. Lyman series, N1 is 1, Lyman. Last line, N2 is infinity. Last line, limiting line, marginal line is one and the same thing. Okay, you put the value and it is your hydrogen spectrum. So Z is 1. Am I right? Z is 1. And R is 1.1 into 10 raised to power 7 per meter. In this case, your wave number will come, but to calculate energy, after calculating wave number, you apply wave number is equal to 1 by lambda if the question comes regarding calculation of the wavelength. And how to calculate frequency, you know, C is equal to nu lambda and nu is equal to C by lambda. So C is equal to, C is a velocity of light, nu is a frequency, lambda is a wavelength. That comes frequency is equal to C into wave number, because wave number is equal to 1 by lambda. So answer is frequency is equal to velocity multiplied by wave number. So again write the question and also the answer. The question was calculate the frequency of the last line of the Lyman series. The answer is 3.29 into 10 raised to power 15 per second. Next question is calculate the wavelength of the first line of the Balmer series. First line of the Balmer series. So Balmer series, N1 is 2, first line is this, so N2 is 3. It's very simple question regarding calculation of the wave number, wavelength and frequency of the various lines. Right, Lyman, you can write Lyman, for Lyman series, N1 is equal to 1, for Balmer series, N1 is equal to 2, Paschen 3, bracket 4, Puffant 5, one more Humphrey 6. So this is all about your questions related with the Bohr's model. At the end I am giving you some conclusion regarding the Bohr's model. Write down few of the points. For calculating angular momentum, NH by 2 pi. Second formula is under root L into L plus 1 into H bar or H by 2 pi. Write down conclusion of the all topic. These two formulas related with the angular momentum of electron in orbit and in shell, in a subshell. Next, second is, this is your first point. Second is radius in angstrom 0.53 into n square by z in angstrom. Velocity of electron in any of them is 2.188 into 10 raised to power 6 per meter. Velocity is per meter per second. It is into, velocity is into z by n. And what your energy? Minus 13.6 into z square by n square electron volt per atom. About one more energy in a joules, minus 2.188 into 10 power minus 18 into z square by n square joules per atom. Now one more thing you can write, E2 minus E1 greater than E3 minus E2 greater than E4 minus E3 greater than E5 minus E4 and so on. So this is your questions related to the topics and the questions related with the Bohr's model calculations. So very important Bohr's model we have completed. About theoretical detailed theory of the Bohr's model I have already taken. Today we have done how to calculate angular momentum, energy, radius, velocity, total number of spectral lines, etc. So after you can write few questions more. Calculate the wave number. Write down first question of MCQ type. Wave number of the first line of the Balmer series is, wave number of the first line of the Balmer series is given. It is 15200 per centimeter. The question is calculate the wave number of the first line of the Balmer series. Calculate the wave number of the first line of the Balmer series and lithium 2 plus spectrum. Again listen, the wave number of the first line of the Balmer series is 15200 per centimeter. The wave number of the first line of the Balmer series of lithium 2 plus, it was given, it was 15200. It is the wave number of the first line of the Balmer series. It is given, but case is given. Case is different. Case is hydrogen. But now you have to calculate again the same wave number of the first line of the Balmer series, but the case is now it is lithium 2 plus. You have to calculate this. Now formula you can apply, wave number is equal to R 1 upon N1 square minus 1 upon N2 square into Z square. So this is given, just Z square is different. Your answer will come only putting the Z square here. Rest is same. Your answer is, it is 136,800. 136,800 per centimeter. So in this way you can calculate the wave number of the lithium 2 plus spectrum. So this is all about regarding MCQ of Bohr's atomic model in the structure of atom. In the next session I will take de Broglie equation, Heisenberg principle and quantum mechanical model. Thank you.